Saxon's Trig, lesson 69, is about matrices and determinants. I find this to be a very fun lesson. Since it is the first time we've talked about these, we need to talk about the terminology. What is a matrix? And matrices are plural for matrix, talking about more than one of them. So a singular is a matrix, not to be confused with the movie that dealt with matrices, or the Matrix. So it is a arrangement of the coefficients from equations, and then we learn to manipulate them in a new way other than substitution or elimination, but we're not quite there yet. So basically you need to know that each and every piece or number that you would find within a matrix is called an element, and they're usually in a rectangular or square looking format. So you see a whole bunch of examples here. I'm just going to write this first one. So this would be representing the coefficients being pulled off of an equation, two different equations. And I need a way to know that this isn't just random numbers, that I do want it to be coming from an equation and to be a matrix. It has this lovely little symbol here, kind of like the absolute value with the extra tabs on it. That way you don't get it confused with absolute value either. All right, so now that you kind of understand this is an element, this is an element, let's talk about how we name them. It goes by rows, then columns. So this one has 2 rows and 3 columns. We would call this a 2 by 3 matrix. If I wrote it as 4, 2, 3, 1, 7, 9, this would be a 3 by 2 matrix, 3 rows, 2 columns. So now you get the idea of how we name them. You understand that each piece is an element. And okay, dimension we just did. Oh, entries are also elements. That's the same word, but they always use elements, but for some reason they tell you it's also named entries. I've never seen it called entries anywhere else. At the very bottom of 437, it says, if 2 matrices have identical numbers, then they are equal. This one would not equal this one because they're different sizes. But if I had 4, 2, 7, 3, 5, 5 for another matrix, these two would be equal because they are identical. But if I change any piece of it, now they're no longer identical. And I think instinctively you would probably have known that. Now, how can we use matrices to help us begin to solve things? So before we get into the nitty-gritty of pulling them from equations, they want to teach you in part B determinants. So a determinant is the absolute value of doing a multiply of, at the moment, a 2 by 2. Later we will get into a different sizing, but for right now, let's stick to the smallest one, which is a 2 by 2. So we're going to go A, B, C, D. So in a determinant, I am doing the cross, wow, I'm saying this badly. Instead of having this in an absolute value, let's say that this was a matrix presented to me, and I say find the determinant of this matrix. You're going to do C times B, and that is heading up toward Canada, and Canada is cold, so we negate the sign. A times D is heading toward Florida, which is warm, so we keep its sign positive. We don't change its sign. And then the reason I wrote it in what looks like an absolute value, it isn't, it means determinant, is that, and again, why they use the same symbol for absolute value and determinant. The way you're going to know the difference is obviously if you've got multiple numbers in a rectangle or square format, it's looking for determinant. Otherwise, if you just have a single number in that same symbol, then you know it's absolute value. Okay, so when you do the Florida to Canada cross multiply, you get a single answer, and that is the determinant. All right, hopefully I've not horribly confused. Oh, and then you need to subtract those two. So the determinant would actually be, if I wrote it A, D, minus CB because you're changing the sign of that one. So you could also say it's plus the negative of the CB if it kind of helps you fit with the Florida to Canada change. All right, so example 1. It definitely looks like an absolute value sign. However, it's got multiple numbers in it. So we know that we need to find the determinant. Where did these numbers come from? Well, they came from a matrix. Okay, so now we do 2 times -3 is -6, but that's Canada, so we make it +6. Plus -4 times 7 is -28. That one went to Florida. Don't change its sign. Combine -28 and 6, and you get -22, and that's the determinant. And I won't get into why we need the determinant until another lesson. Example 2, same kind of thing. -7, 3, 5, -4. We know it comes from a matrix, but we're just going to do -7 times -4 is +28. Toward Florida, don't change the sign. 3 times 5 is 15. Toward Canada, change the sign. 28 minus 15 is 13. There's the determinant. Example 3. This one shifts gears just a little bit, and it gives you an x plus, 4, and then the 3, and then a 2, 4, and it still asks for the determinant. So this one, when we do x plus 4, remember that's like a parenthesis, it's multiplying by 4, so that's going to distribute. 4 times x is 4x. 4 times 4 is 16. Now that's Florida, so no change to signs. 2 times 3 is 6, Canada. Change it to -6. And then combine that together so that we get 4x plus 10. And it said to solve for the x, which means I need to set this equal to, not equal to 0. The problem told me this equals 18. I knew that didn't seem right. Equals 18. Now that's fixed. So 4x minus 10 equals 8. X equals 2. We've solved for that. And then there is another example 4. Again, having the extra pieces in here, so it's giving us x plus 4 over 3, 5, and x plus 2, and it equals -5. Okay, so we do our Florida to Canada. X plus 4 times x plus 2. Ooh, that's parenthesis times parenthesis. So I need to be careful that I distribute every part or FOIL, depending on how you want to call it. So x times x is x squared. X times 2 is 2x. 4 times x is 4x, and 4 times 2 is 8. All of those went to Florida, no changing of their signs. 3 times 5 is 15, but it did go to Canada, so we change its sign, and that equals the -5 that it gave us. So then x squared plus 6x, these like terms 4 and 2, and then 8 minus 15, -7 equals the -5. And since I'm trying to solve for x, I know that I need to make this equal to 0 and see if I can factor it. So x squared plus 6x plus the 5 over here keeps that at -2, and now it equals 0. Can we split this into 2 parentheses, or do we have to quadratic formula? X and x make the x squared. Is there any way to do 2 and 1 and make a 6? No. So I know that I can't factor, that won't work. We have to switch gears to quadratic equations. So A is +1, B is the 6, and C is the -2. Quadratic formula. -b, so -6, plus and minus the square root of b squared, 6 squared is 36, minus 4 times a times c, all over 2 times a. That's your quadratic formula. So once again, that's -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And the 4 and the 2 come memorized in the formula. -6 plus or minus the square root of 36. -4 times 1, -4 times -2 is +8 all over 2. -6 plus or minus the square root of 44 all over 2. 44 can split to 4 and 11, 2 and 2. So I know I have a set coming out, -6 plus or minus 2 root, and the 11 is stuck inside, all over 2. Can I reduce all of the outside numbers by 2? So -3 plus or minus root 11, because this 2 went in here and left a 3. Dividing by 2 is 1, dividing by 2 is 1. That made the 3. All right, and that's how I got to here. And those would be my two answers, one being positive, one being negative for x. And what they chose to show you for some odd reason is them putting these answers back into the determinant. And that's not part of what you're supposed to necessarily do. It just said solve for x. So if you get to here and you box, those are your answers for x. Why they show you tossing them back in, I don't know. But what they did then was they basically kept their plus root 11 and they took the -3 and added it with its like term 4 and got 1. So they filled in here 1 plus root 11, the 5, the 3, and then they did the same thing, -3 combining with the 2 and got -1 plus the root 11. And then the secondary answer, they kept that same 1, but you had the minus version with the root 11, and the same thing here, the -1 with the minus root 11 version. So